Okay, so today is the second lesson on number patterns, and today we're going to talk about arithmetic sequences. So what arithmetic means is when you're either adding the same amount or subtracting the same amount. So arithmetic, adding or subtracting in the sequence. So remember, a sequence is a set of numbers and they've got a rule that they're following. So an arithmetic sequence equals a rule that contains a term that's either adding or subtracting a fixed amount. So an example of this is simple arithmetic sequence is simple interest. So if you remember back to finance, remember every year the same amount was added on. Yeah, so that's an arithmetic sequence. Or flat rate depreciation, where every year the same amount, so it might have been $100, so $100 came off the original price every year. So that's arithmetic because it's the same amount, yeah? So in all right, so if we look at this first sequence here, so we're going 2 to 7, so what's been added there? 5. And you can see that 5's added here. So the rule for this sequence, you'd say to find the next term. So remember, they're called terms, each little number. You would add 5 to the current or the previous, whichever way you want to look at it, term. Okay, if we look at the next one, what's happening there? So the same amount is getting taken away. Isn't it minus 5? Yeah. So to find the next term on that one, we're going to take away, subtract 5. So from the current. So the one you're on, you know you subtract 5. Okay, so see how if you have a look there, that when we're subtracting 5 or adding 5, that becomes known as the common difference. So in the first one, the difference is that it's 5 is added on. And in the second one, the common difference is negative 5. So 5 is taken away. So we use that symbol D down there to represent what the common difference is. So here in this one, D would be 5, and this difference here is negative 5. Okay? So you can find what D is by subtracting any term with the one before, which is what you were doing in your head. You just, when you were trying to work out what the difference was, you saw that between 7 take away 2 was 5. You knew that there was a difference of 5. So that's what we're doing. So we go on to the next bit. So you can find here, as we said, so if you were on term 2, if you take the one before away from it, you'll get the difference. So it doesn't matter even if you use term 4 and you take term 3 away, you'll get the same thing. So if I look at this example here and they say, what's the difference? So this is this would be T1 and this is T2. So I could say 25 minus 30 equals negative 5. So you can see I can find out that where negative 5 is the difference. So identifying the arithmetic sequence. If a sequence is arithmetic, the difference will be constant. It means it's going to be the same amount. So that's why simple interest and flat rate is an arithmetic, because it was always the same amount. If you remember simple interest, if you were going to get $20 a year, you were going to get $20 every year. That's what the difference was, yeah? So which of the following sequences are arithmetic? So what we might do is we'll take a term and we'll subtract it. So see here, if I say T2 minus T1, so that would be 28 minus 21 equals 7, sorry. And then if I tried the next one, if I said T3 minus T1, I'd get 35 minus 28. And does that equal 7? It does, doesn't it? Yep. So you can see that is an arithmetic because it's always the same amount every time. Now, if we test the next one, we'll have a look. So if I did, the difference was 6 minus 2, that would be 4. And then if I do because this could be T3, T2, if I do 18 minus 6, well, that equals 12. They're not the same, are they? So that one is not. So this one's an arithmetic sequence, and the other one is not. So I might say yes and no for that one. Okay, so if on your calculator, and you can just test this later and come up and check with me if you're not working. So what you can do is, if you're trying to put an arithmetic sequence into your calculator, say for example we had the before, so I might say for example the sequence. So sometimes we write how we get the next term is you take the term that you've got. This is how you write what I'm saying mathematically, yeah? So this n plus 1 is a way of saying in maths how we get the next term or number in the sequence. That's all that means. Yeah, and then you could use the one you've currently got and add 5, okay? So what we said is they said, all right, that was the sequence and start with 2. So on your calculator, you press 2 and then press enter so that it sits over there. Then if you actually press plus, you'll see that answer comes up. You press plus and add 5. That means it will add 5 and you'll see 7 appear. Okay, and then after that, you only have to keep pressing enter. The calculator knows now you want to keep doing that. So you just keep pressing enter and you'll see that it keeps doing the sequence. So you don't even have to worry too much, and you just can do that. When they get a little bit more, it's easy to add 2, but when it gets a bit harder or there's something like you're adding a fraction or something, you don't have to stress, you just pop it in like this. Okay, so check that later when you're on your calculators. When you graph an arithmetic sequence, and if you remember simple interest looked like a straight line graph, and it shouldn't it? Because this would have been your starting amount, and then every year you got the same amount of interest or something, so the value went up. So when you graph an arithmetic sequence, you should see a straight line. If it's adding, it would go up. If you're subtracting, it would be going downwards. So you've got to make sure that an arithmetic, so you might be able to identify the sequence is an arithmetic because the graph, if they gave you a graph, if it was a straight line. Okay, and then this one, sorry, the arithmetic the sequence 4, 7, 10 is an arithmetic sequence with a common difference of 3, which we hopefully can see there, that we're adding 3 on there. Okay, construct a table. So we've got to finish the table. So what would term 4 be? You're going to add 3, which would be 13. Term 5, 16, good. Term 6, 19. Beautiful. If we had to, graph that sequence there. So you can see here we've started on 1. 1 was, when you're at 1 it was 4, and you went up, and the last one you would see is 6 and 19. You'll see it's a straight line. Okay? So if you graph that and you went up like that. All right. I'm going to stop it there, and we're going to do the next one as well.